We are continuing the chapter Pressure of Physics, which I divided into 15 different points in previous class, and till 8 we finished in last class, and we are starting with point number 9, that is floating and sinking today. Okay, we don't have to define floating and sinking, just the floating and thus the sinking is not the big matter, but I want to tell you why a body floats or sink in a liquid. Now, this is the condition. Let's say there are three bodies shown in this diagram. One is floating, one is sinking, and third one is suspended inside the liquid, neither sinking nor floating. Floating means a part of it is inside the liquid, a part of it is outside the liquid. And sinking means it is completely inside the liquid and landed at the bottom. But suspended means neither it is sinking, not landed at the bottom, but completely immersed into the liquid. Now, if you are asked to write about this, I mean to say, if you are asked in which condition a body floats or sink, write down according to density, or without the density also. If you have to answer, you can answer this way. Let's say this is floating. A body floats when its density is less than liquid. If density of solid is less than density of liquid, then it floats on the liquid. But if the density of a solid is greater than density of liquid, then it sinks in the liquid. And if the density of a solid is equal to density of liquid, then it remains a suspension inside the liquid, maybe near to the surface or maybe towards the bottom also. This is the answer of floating and sinking, the reason of floating and sinking. But I want to tell you something more about this. Okay, what about the upthrust? We know about the upthrust. When a body is placed in a liquid, then liquid exert or resultant upward force on the body, that is called upthrust. Now, compare the upthrust acting on these three bodies. Let's say this is A, this is B, and this is C. If you are told that compare the upthrust acting on these three bodies, then how can you answer the question? So there is a big confusion in the students. They think that upthrust on A is greater than B and C, that's why it is floating, but this idea is completely wrong. Upthrust on A is less than B and C, because according to Archimedes principle, upthrust is equal to weight of displaced liquid. And look at this, if their volume is equal, the condition should be the volume is equal. The question should be like this: if A, B and C, all of them have same volume, which one experiences less upthrust? Then you can say A experiences less upthrust, because according to Archimedes principle, upthrust is equal to weight of displaced liquid, and A is displacing less amount of liquid. This much is the immersed part, and less amount of liquid is displaced by A. So upthrust on A is less in comparison with B and C. So A experiences less upthrust. But what about B and C? Both of them experiences same upthrust. The reason is very simple. Both of them have equal volume, and according to Archimedes principle, upthrust is equal to weight of displaced liquid. They displace same amount of liquid, the same weight of liquid. That's why they experiences same upthrust. Now this is about the upthrust. Now next question may be like this also. What is the weight of A, B and C? Then you can say that weight of A is 0, B also 0, but C has certain weight. The question may be like this also. Weight of a floating body is 0. Why? Why weight of A is 0? This is one of the simple question. A floating body weighs 0. What it mean? How it weighs 0? Your answer should be like this. According to principle of flotation, weight of floating body is equal to weight of displaced liquid. And according to Archimedes principle, weight of displaced liquid is equal to off thrust. Off thrust is vertically upward force and weight is vertically downward force. In case of floating body, both of them are equal and acting in the opposite direction. They cancel each other and resultant force, that is the weight of floating body, is 0. Now if you are asked about B, then you can say in case of B also weight is 0. Why weight is 0? Because weight is downward force and it is neutralized by the off thrust. That's why the body is not landing at the bottom. Off thrust is neutralizing the weight of the body. That's why the body is suspended. So the resultant force, that is weight of B, is 0. But C has certain weight. How can we say that C has certain weight? Because in this case, the off thrust is not able to neutralize the weight force acting on the C. I mean to say, weight force acting towards the center of the earth is not neutralized by the off thrust. Weight is more, downward force is more. That's why it is landing at the bottom. So weight of C is more than B and weight of B is more than A. Okay, now how can we say weight of C is more than B, and if you are told to compare weight of C is more than B and weight of B is more than A, then how can you prove that weight of B is more than A? You can say this way: both of them have if equal volume, then according to Archimedes principle, off thrust in A is equal to weight of displaced liquid by A, which is less than B. And in case of A, off thrust is neutralizing weight, but in case of A, off thrust is neutralizing weight, and off thrust is less. That's why weight of A is less. But in B, the weight of displaced liquid is more, off thrust is more, and more off thrust is neutralizing the weight of B. That's why weight of B is more than A. In case of C, how it is heavier than B? It is heavier than B because the off thrust is equal in A and B, but off thrust neutralized the weight of B, but it cannot neutralize the weight of C. That's why C is landed at the bottom. In this way, we can say that weight of C is greater than B and weight of B is greater than A. The question, actually, this is very simple. We can compare according to density also. We can compare their weight also. We can compare the off thrust acting on each of them also. This is all about the floating and sinking related to your syllabus.